Now we'll look at what happens when we perform inference. Now I'm going to create a new network, this time with a utility variable, so that we can look at the outputs that we get from decision theoretic algorithms as well. Our prediction target is variable 6. Let's introduce a decision variable. We can play around at this point and choose to add more prediction variables. As before, we'll attach the testing data and let's perform a test action. And this is, of course, going to assume that the variables we're interested in predicting, we don't actually know their values. Now, there's a few different inference algorithms, but basically they boil down to either being exact inference algorithms, which we are able to use for decision theoretic purposes as well as predictive analytics, and sampling algorithms, which can only be used for predictive analytics, but which give us freedom in the types of conditional distributions that we can include in the network. We can select whether or not we wish the parameters of the network to continue to adapt as we pass new data to the model. If we were going to be performing Bayesian model averaging on a model that contains numerous networks, we could set how we wish to weight these networks. So let's now run a quick inference algorithm. We've gone through and we've done it, and we can see the results. Okay. Now there are all sorts of objects that give us information about the inference action that we've just performed, from posteriori distribution graphs for our prediction variables, confusion matrices for our prediction variables, decision policies for our decision variables, item and whole dataset summary grids. But what it all really boils down to are two quite simple objects. First of all, for each decision variable, we're going to have a decision policy, which tells us the value to which we should set this variable in order to maximize our expected utility, as well as telling us what this expected utility is. If we were in a situation where there are some variables we don't currently know, but whose values we will know by the time we make a decision, we can set it up so our decision policies are conditionalized upon the values that such variables end up taking. The other principal output is, of course, the a posteriori distributions for the variables we wish to predict.